In Chapter 5, we will look into discrete, what is a discrete random variable, how do we calculate the expected value, or otherwise called average or mean, of a discrete probability distribution, how to calculate the variance, the standard deviation for this type of distribution, and we will also look into binomial probability distribution and Poisson probability distribution, which are also different types of discrete probability distributions. So we start with what is a discrete probability distribution. You need to understand that it has to meet the following conditions. Each outcome in the distribution needs to be mutually exclusive. The probability of each outcome has to be between 0 and 1. The sum of all the probabilities of all possible outcomes need to add up to 1. To calculate the expected value, or otherwise called average or mean, for a discrete probability distribution, we have to take the sum of the product of x times p of x. So you will take the probability of each outcome and you will multiply it with the outcome. And then at the end, you will add them all up. Now, we calculate the variance. The variance measures how spread out the results of an experiment are from one trial to the next. The formula for the variance is the sum of x minus mu squared times p of x. That means that for each outcome, you will take the deviation of the average from the outcome, you will square it, and then multiply it with the corresponding probability. And at the end, you add them all to find the variance. Now, the standard deviation of a discrete probability distribution measures the dispersion of the outcomes of the discrete probability random variables, excuse me, the dispersion of the outcomes of the discrete random variables in relation to the distribution mean. The formula for the standard deviation, as always, is simply the square root of your variance. So whatever you find for your variance, you simply take the square root of that, and this will give you your standard deviation. Now, if you were to calculate the mean, the variance, and the standard deviation, you would simply have to complete the following table. You have your outcomes for x, you have the corresponding probabilities for each outcome on the next column. On the third column, you take the product of the first two. At the end of the third column, when you add them all up, this will be your expected value, your average or mean. They all mean the same thing. And on the fourth column, where you take the square deviation of every entry from the mean and you multiply it by the corresponding probability, when you add them all at the end, this will be your variance. So if we were to look at an example on how to calculate the expected value, and again, we call the mean expected value because this is what we expect the average will be in the future given what we have right now. So for this probability distribution, you are asked to find the mean, the variance, and the standard deviation. You write down your outcomes alongside the corresponding probabilities. You take the product of the first two columns for each one, and then whatever you find at the end, you add them and you get the average. So the average in this case is 1.5. Now, you take the average, the mu, the expected value, and you subtract it from each outcome. So you have x minus mu square. So in this case, 0 minus 1.5, which is the mu square, 1 minus 1.5 square, and so on and so forth. Then you add this to the corresponding probability of each outcome, and whatever you find at the end, you take the sum, and this will give you your variance. The variance in this case is 1.675, and to find the standard deviation, all we need to do is take the square root of the variance, 1.294. Now, a binomial experiment has the following characteristics. We need to understand and know the characteristics very, very well. The experiment consists of a fixed number of trials, denoted by n. Each trial has only two possible outcomes, a success and a failure. The probability of success and the probability of failure are constant throughout the experiment. Each trial is independent of any other trial in the experiment, and the number of successes in a binomial experiment must range from 0 to n. N, again, being the number of trials per experiment. The formula for a binomial distribution is the following. You have n factorial over n minus x factorial times x factorial, and this times p raised to the power of x times q raised to the power of n minus x. Keep in mind that x is equal to the number of successes in the trial, n is the number of the trials or sample size, p, we use p for the probability of success, and we use q for the probability of failure. Since the only possible outcomes are success and failure, when we add the two, so for this, p plus q will always add up to 1, which means q will be 1 minus p. Now, the mean of the binomial distribution represents the long-term average number of successes to be expected based on the number of trials. The formula for the mean of the binomial, and once again for binomial distribution, is simply n times p. You will have both entries. You will have the sample size and you will have the probability of success. In binomial probability distribution, in all the problems that you will have to solve that involve binomial probability distribution, you will always be given n and p. So to find the expected value, you simply find the product of the two. Now, for the variance in a binomial probability distribution, all you need to do is n times p times q. Q, once again, is 1 minus p. If you have p, you can automatically find q. And the standard deviation, obviously, the square root of your variance, whatever you find for the variance. Now, for binomial, the easiest way to calculate the probability, instead of using this formula, is to use your graphing calculator. All right, that's the fastest way. So you want to go to second, click on vars, and then move on to binomial PDF. So if you had your graphing calculator, I have the 83. The 84 is slightly different, but equally, the steps are the same, but you will have a different screen where you just simply have to go to calculate. You go to second, vars, and you scroll down to binomial PDF 0, and then you have n, comma, p, comma, x. If you have the 83, the comma is right above 7, and you have to place it in this order, n, comma, p, comma, x, close parentheses, and enter. If you have the 84, it will automatically give you trials, probability, and you just plug in the numbers. You don't have to memorize the order that you have to put it in. So it's a lot easier with an 84. So n, comma, p, comma, x, and it's a lot faster. Let's look at an example. The probability to pass Math 151 is 0.8. So this 0.8 is your P. A sample of 5 students is given. This is your N. What is the probability that 4 students will pass the course? So what am I looking for? I'm looking for the probability of X to be equal to 4. So if you were to use the formula, you would have 5 factorial over 5 minus 4 factorial times 4 factorial times P, which is 0.8, to X, which is your 4, 1 minus P, 1 minus 0.8, raised to the power of 5 minus 4. This would be 0.4096. If you were to use your graphing calculator, however, this would be a lot easier. You would do 5, comma, 0.8, comma 4, close parentheses, enter, 0.4096, a lot faster. What is the probability that at least 4 students will pass the course? And with binomial specifically, you want to be very, very careful on the words used for the probability that you're looking for. So you want to be extra careful of what the question asks. If you want x to be equal, less than, at least, maximum, the most, and so on and so forth. These are keywords that you need to be able to translate accurately with the correct signs. So at least 4 means that you're looking for the probability of x to be greater or equal to 4. X greater or equal to 4 means that you want your x to be equal to 5 plus x to be equal to 5. So greater or equal to 4. This will be probability of x to be equal to 4 plus the probability of x to be equal to 5. Why do I stop at 5? Because n is equal to 5. You will only go up to your sample size and all the way down to the probability of x to be equal to 0. So you do binomial PDF for each one and you add them. And this should be your answer. Now, for the same problem, I want to calculate the expected value. This is your E of x, or otherwise called mu. The variance, this is your sigma square, and the standard deviation, this is your sigma. So we start with the expected value. For binomial, we simply take the product of n times p, 5 times 0.8, your average is 4. For the variance, n times p times q, 5 times 0.8 times 0.2, and this is 0.8, and then you take the square root of 0.8 and you get your standard deviation, which in this case is 0.8944. Now, for the Poisson distribution, a Poisson process has the following characteristics. The experiment consists of counting the number of occurrences of an event over a period of time, area, distance, or any other type of measurement. The mean of the Poisson distribution has to be the same for each trial. The number of occurrences during one interval is independent of the number of occurrences in any other interval. Mathematically, with Poisson distribution, there is no upper limit to the number of occurrences during the interval, which means that when you have Poisson distribution, the only information that you will have will be an average. So the probability of x for a Poisson distribution will be lambda squared times e to the negative power of lambda over x factorial. Lambda is the mean or average. So you can have lambda or mu sometimes. We will be using lambda. Lambda is a lowercase l in Greek alphabet, and it's the average for Poisson distribution. And x is the number of successes, what we are interested in. The variance in the Poisson distribution is equal to the mean. So this is one of the properties of Poisson distribution that we should all be aware. And then again, if you were to calculate the standard deviation, you would simply take the square root of your average. Now, instead of using the formula, we will be using our graphing calculator. So by doing second, right here, second, vars, and scrolling down to Poisson PDF, press enter, and then the order that you're going to enter your information will be lambda, x, mu, x. So make sure that you remember the order that you have to enter your information, and then you click enter. So let's look at an example of how we'll know that we have Poisson distribution. Carrie has an average of 7 assists per game. Assume that the number of assists follows the Poisson distribution is stated. What is the probability that Carrie will have 6 assists for the next game? So you're looking for the probability of x to be equal to 6. Now, using the graphing calculator, you will go second vars B, Poisson PDF, lambda, this is your lambda, your mu, your average, 7,6, which is your x, enter, 0.1490. So this will be the probability. So these are the notes for chapter 5.